Adventures with citizen scientists.
I tell people all the time, if you're pessimistic about the world, work with Girl Scouts.
And a 2.5-minute spectacle will draw thousands to Wyoming this summer.
It's quite the experience, because the only time you can see the corona is during the eclipse. And it's something that you'll tell your grandkids about.
Welcome to this edition of Wyoming Signatures. Good evening, I'm Mary Young. Tonight we start with how a presidential order is impacting our state. Here to say more about how pausing research grants by the Environmental Protection Agency may affect classroom education and the Wyoming economy is Bill Gurn. Gurn is the retiring Vice President of Research and Economic Development at the University of Wyoming.
Recently, President Trump ordered a pause to EPA research grants. How does an order like that impact the University of Wyoming and other universities that receive federal research dollars?
Well, right now it's uncertain. Of course, we pay attention to presidential directives. We don't know if it is going to affect our continuing grants that we have operating right now, or any new grants. So we're waiting for instruction, basically from the agencies.
For persons in your position who oversee large research areas at universities, how does the last few years of political discourse and what's happening right now, how does that influence your planning for research? Does it affect what you are seeking, or do you still leave faculty open to pursue their own interests?
Yeah, that's a really good question. And I would say for the most part it's laissez-faire. We hire faculty because they're experts. They're experts in a specific area, and they will remain experts, hopefully, while they are serving their tenure at the University of Wyoming. But we also do pay attention to presidential directives. For example, there was a recent presidential directive about focusing on food, energy, and water. Of course, three of those areas speak directly to things that we do at the university. We're very interested in agricultural production. We have a very strong water research program, and of course, we are trying to be world-class in energy-related science.
Now, the most recent numbers I saw had the university receiving $95 million in research funding, external research funding. How much of that is through federal funds, through state funds?
Sure. It's about 3/4 of it is federal. About another 20% or so of that remaining is coming from the state of Wyoming. And then the last comes from industrial and others. So others would be non-governmental entities, for example.
So government spending is at the top of a lot of to-do lists for individuals that the president is appointing to his cabinet and to head agencies. When we look at the funding sources for research, why should that be a concern to Wyoming residents?
So as you look at the overall federal budget, it's divided into now three important areas. There's non-discretionary. So these would be Medicare, Medicaid, for example, are the big pieces of the non-discretionary budget. That means that there's not much ability for Congress to do anything in those areas unless they make landscape kind of sweeping changes. So they look at the discretionary budget, and almost everything else that is done in government is done with the discretionary budget. So that's the budget that we investigate space with. It is the budget that it funds the National Institutes of Health. It is the budget that we build roads with. So that is the budget that most people in America see relative to how our federal agencies operate.
So when we look at the types of topics that we're researching here at the University of Wyoming, what are some of the ones that have national interest? What are some of the ones that have state interest, and where do those kind of overlap?
They overlap surprisingly well for the most part. For example, we have a very strong interest in water research. We are trying to say that the University of Wyoming is where you go if you want to understand the water column from where it is falling onto the surface of the earth to where it penetrates into the aquifers. We really want to own that research area in a very strong way. And of course, that is a major issue sitting worldwide. The ability of this world to continue to identify sources of fresh water will become a major societal issue, and therefore it is a major research issue. So that's just a good example of that. But water is critically important in Wyoming. It's important for agricultural purposes, it's important for our municipal purposes, and it's also important for industrial purposes. So that's a good example of where it really is kind of a continuum. Of course, what we see at the federal level is somewhat different than what we see at the state level, because at the state level, we're really funding very important projects that lead to policy decisions that may be made by the state legislature. It informs state agencies about things that they should or should not be doing. So that research is, the state research on water in this case, is fairly applied. It is a results-oriented research that can be directly placed into action in some way or another. On the other hand, some of the research that we're doing with the federal government is more fundamental. How do you really do a proper model of, say, water allocation in the upper Colorado River Basin? That requires large-scale computing. A lot of fundamental computer science and computational science is done in that area. So we can stretch across this continuum of research.
So you mentioned that outside research, the external research, a small portion of that comes from industry. Why is that?
It's interesting. Industry recognizes that universities have experts, and they're interested in what those experts can do for them. And so industrial research is an important area. That's a research area that really speaks to the amount of industry that is in the state. So if you were to go to Michigan, you're going to find a lot of mechanical engineering research because they build cars and other things in Michigan. In Wyoming, that industrial research deals more with natural resources, coal, oil, gas, trona. And there are some research universities that are so large or so well known that they just do a lot of different kinds of industrial research. A good example of that would be MIT. They do all sorts of industrial research.
So how much does industry and business depend on research that the government is funding?
Well, that's an interesting question, as a matter of fact, because if you look at the trends in industrial research, you'll see that more and more industry is closing down or vastly reducing their R&D divisions. So it used to be that Bell Labs was a really important industrial laboratory. You don't find them anymore. So they are depending more and more on research funded by the federal government at universities, and then the way they approach it is through their mergers and acquisitions. So they would rather come in, identify a research project that might have led to a technology transfer of some type, and then they acquire that transferred technology, either by acquiring a startup company or by licensing the technology directly to the industry. So you're seeing a change in the industrial landscape from, like I said, their own R&D to now mergers and acquisitions.
So there's a real interest in what the federal government does with budget, with taxes, with how it appropriates funds for research by industries across the country.
Absolutely. For example, some of the largest technology transfers that are done by American universities are basically pharmaceuticals, and they get transferred immediately. They're picked up by industry, and then those pharmaceutical industries are the ones that then push forward all of the FDA clearances and things like that. But they're not having to spend the money on identifying and developing, doing basically the pharmaceutical chemistry to develop the drugs in the first place. That's just one example, and there are a lot of other ones.
Well, thank you for being with us again today.
Yeah, it's my pleasure. Thank you for inviting me.
Continuing with research, you could describe it as crowdsourcing scientific help. The University of Wyoming Biodiversity Institute calls it citizen science, and it's easy to find recruits in Wyoming, where so many of us love the outdoors. Institute Director of Science Programs, Brian Barber, explains how Wyoming citizens are getting involved. Brian, thanks for joining us today.
Thank you.
What are citizen scientists?
A citizen scientist is someone that is not a non-professional that becomes involved in some form of research project.
How do you use them?
Most often they're used as data collectors. So a researcher has a question, a research project that requires data, usually over a large geographic area. And it might be time sensitive in the fact that we need to collect those data over the course of a weekend or a week. And the manpower in that person's lab doesn't exist, so we will recruit volunteers from the public to go out and collect those data.
Can you give me an example of a project that's occurred recently?
Yes, so at the Biodiversity Institute, one of the projects we've done, one of the citizen science projects, is Moose Day. So Moose Day is a single day event. We do one in the winter and we do one in the summer. They occur in Vitavu, Pole Mountain, and the Snowy Mountains. And we allow participants, the public, to pick their own route. And they go out and early in the morning, and we found that from the past 3 or 4 that you see 90% of the moose before 9 a.m. So in the winter, this might be a little more of a challenge. But they go out, they do the route, they can take family members, and then they come back with a data sheet with the number of moose they've seen, number of moose signs, so tracks and scat.
Sounds like a lot of fun.
Last year on the winter one, we had a retired man who basically told his daughters that they were going to drive him across Nebraska because he wanted to do his route in Wyoming and see some moose. So it was kind of fun.
Is this a new idea?
The idea came from nature mapping in Jackson Hole. So they've been doing a Moose Day in the valley in Jackson since I think 2009. And we thought, well, why not do one here? We have moose here. We know we had a public that would be interested in doing something like that. So kind of with their guidance and input, we designed our own project here.
Can you trust the data that you're getting from these helpers?
The answer is, for the most part, yes, it can be, either through adequate training or just kind of the volume of data. Another one of the projects we have at the Biodiversity Institute is a Rocky Mountain Amphibian Project. And we have kind of replicated, so I'll give you some background into that project. So you can adopt a stream catchment in the Snowies, and you go out and you look for frogs, right? Frogs are on amphibians in decline worldwide, so we'd like to monitor them and see any population changes and where they're occurring. So, and they get some training, they get some online training, and then they can come and talk to us. They get a little kit, they go out there. But one of the things they did was go back with the professionals in the same catchments and kind of verify the public's, the citizen science ability to capture this data. And in some cases, they were actually better than the professionals. They had more detections of amphibians in those catchments. So.
How long has the Biodiversity Center been using this approach, and has it been successful?
I think it's very successful. We've been doing it basically for the last 2 or 3 years. We've been really pushing it in the sense that we have actually had our first, we sponsored the first Wyoming Citizen Science Conference in Lander just in December 2nd. And we're hoping to expand that to be more of a region-wide thing, so Montana, Utah, and Idaho. We feel there's a need for that in the region. And one of the things we hope to become the leader in that area so that we'll serve as kind of a clearinghouse for other projects to share knowledge, share experiences with citizen science projects.
Tell me about your work with the Girl Scouts.
Oh, the Girl Scouts. Well, a little bit. So, like I said, a lot of the citizen science projects, the public are contributing data. But on the flip side of that, to become involved in the scientific process, there's a lot of steps. There's a lot of stages of inquiry. Develop hypotheses, collect data, analyze those data, and disseminate it to the public. So one of the things I thought would be fun was to find a population of students or public that might be willing to experience the entire scientific project on a research question. And so we got Laramie Girl Scouts, about 12, that I spent the year with. And we looked at the recent stream restoration in the Laramie River. Was it effective? And instead of being the academic and telling them, these are my questions, here's what I want you to go do, I just said, look, this has recently happened. How would we look at this to determine if this was an effective use of money to restore the river? So they had to generate questions, they had to generate testable hypotheses, and they put waders on and they went out in the stream and they caught critters and they did everything.
Did the Girl Scouts get anything out of this?
They, I think, had a much more sense of that science is doable, that I can do science, that it's not that thing on the hill in the ivory tower that people do. And in fact, I would argue that most of those girls could do a science project on their own now. I tell people all the time, if you're pessimistic about the world, work with Girl Scouts, and it'll change your view of society and our future. So they were wonderful.
This sounds like a great way to recruit women into science.
That was actually one of the purposes of the Girl Scouts project. So this was funded through an EPSCoR, Wyoming EPSCoR grant. And it was basically to expose these young ladies to female role models on campus. In fact, I was the only man in the entire project, and I tried to stay in the back. So on top of doing the research projects, we had these evening, what we called water workshops, where they would meet female faculty and do something related to water. So not your traditional citizen science, but they were learning how to collect data, how to identify organisms, so all parts of a scientific pursuit.
Brian, thanks for your involvement. Thanks for sharing it with us.
Thank you.
This summer, on August 21st, an amazing spectacle will occur over a swath of the United States and other parts of the world. These places are along the path of where viewers can witness the full effect of a total solar eclipse. Associate Professor of Physics and Astronomy Mike Pierce shares details.
What is a solar eclipse?
The solar eclipse occurs when the moon passes directly along the line of sight from someplace on the earth towards the sun, so that it covers up the sun's bright atmosphere that we see every day completely.
And are there different types of them?
There are different types. There are partial solar eclipses when the moon covers part of the sun, sometimes even most of the sun, but still leaves like a little sliver. And there are also eclipses called annular eclipses when the moon is too far away to fully cover the sun. So it looks smaller from the earth, and so it leaves a little ring, and that's called an annular eclipse.
And which is the most common type of eclipse?
Well, the most common would be the partial eclipse, because over most of the earth you can see the moon partially covering the sun. But solar eclipses are very rare. It requires just you being in exactly the right place at the right time for the sun to be fully covered.
Okay. We have a total solar eclipse coming this summer. Can you tell me a little bit about how rare that is and what this means?
Yeah. So eclipses somewhere on the earth, total solar eclipses, occur once or twice a year. But because everything is in motion, that is, the earth is turning, the moon's going around, and the moon's orbit is inclined, to the earth's orbit, we don't get an eclipse every time the moon is new when it's going through its phases. So most of the time, from any given place, like in Wyoming, the moon is like above the sun or below the sun, just simply the alignment is missed. But the last time there was an eclipse, total solar eclipse in Wyoming, was about 100 years ago. And in fact, Thomas Edison actually came out to Wyoming to see that eclipse. So it's kind of well known, that he was a visitor then.
What does a solar eclipse look like if you're directly under it?
Well, if you're directly in the path of totality, that means that the bright sunlight that streams to Earth gets completely covered. So we're in the shadow caused by the moon. And so what you see is kind of a ring around the sun. It's called the corona, which is, I think, Greek for crown, because it looks very cloud-like and filamentary, and it's quite the experience, because the only time you can see the corona is during the eclipse. And it's something that you'll tell your grandkids about.
So if you're in other parts, if you're not in that line of totality, what does it look like? Do you even know that anything's really going on?
No, it's very hard to tell, because even though the sun is theoretically getting darker, your eyes just adapt, and you hardly notice that the sun's being eclipsed at all. But along the path itself, there are all these phenomena that occurs. It, of course, gets dark. It's about the darkness of twilight, like when the moon is out. So you can still see, but it's quite dark. Animals react, birds will roost, they'll start their chirping and all of that as they are going to sleep. And then, of course, they wake back up or become active again when the eclipse is over. Yeah.
So how does the state of Wyoming and Casper specifically fit into this summer's eclipse?
Well, there's, as you can imagine, there's a lot of excitement building up. People are getting quite excited about this because it's so rare. And you probably also are aware that it only lasts a couple of minutes, 2.5 minutes in Wyoming, in fact. And so the path goes right over Casper. And Wyoming is a popular spot because being in August, it's expected that the weather will be extremely good. Because there are people flying from all over the world to come and see this. And if you come and it's cloudy and 2.5 minutes go by and you miss the eclipse, that's it. Yeah, chance of a lifetime is gone. So Wyoming is very interesting to a lot of people, and so they're coming from all over the world.
How many people are expected to come from around the world?
Well, it's uncertain, but the best estimates are about 500,000 people will come to Wyoming to see the eclipse. So the population will roughly double. I think Casper is expecting roughly 30,000 people. So their population will double, and they're expecting a number of events, they're planning a number of events the week before. And so there's a lot of interest all across Wyoming.
Is Casper ready for that amount of people?
I hope so. I've been to some planning sessions, and I think the Chamber of Commerce and other businesses and first responders and other people are very aware of the event. And the Wyoming Tourist Bureau is also involved in helping communities to organize and be prepared for this big influx of people.
Okay, so tell me a little bit about the projects that you're working on for the week of the eclipse, or that day.
Yes, so I'm part of a NASA-funded project where we plan to deploy about 56 telescopes across the United States, because the path of totality will begin in Oregon and go through Wyoming, of course, and then exit on the Atlantic coast in South Carolina. And so our plan is to deploy telescopes about every 50 miles or so that each telescope records 2.5 minutes of the eclipse, and then we'll splice it all together to make kind of a time-lapse movie showing the structure of the outer atmosphere of the sun and how it changes over the 90 minutes that we'll get by splicing all of that together. And it's exciting because we're making use of the internet. This is the first time the internet's really been available, at least in the US, for a major event like this. And we're involving about 50 high schools across the country. So we're going to be training, I think I'm training 8 high schools in Wyoming to help us with the project, and then they get to keep the equipment at the end of the eclipse.
So tell me where you're going to be watching the eclipse.
Well, I'm going to be in Casper at the Girl Scout camp, Camp Sacagawea, up on Casper Mountain. They've invited my group to be there. And we'll probably travel down to downtown Casper, perhaps Casper College, to set up one of the stations there with a group that's coming up from Phoenix associated with the Exploratorium Science Museum. And they want to provide a live feed of the eclipse, live video feed of the eclipse to their people back in Phoenix.
And are there any safety concerns for the solar eclipse?
There is a safety concern, and first and foremost, you don't want to look at the sun with the naked eye during the partial phases, when the moon is partially covering the sun and the sun is still quite bright. Once the totality begins and it gets dark, and this happens in just seconds, so it's very obvious, it's perfectly safe to look at the sun. There's nothing different about the sun during the eclipse. So even as the moon starts to reveal the bright sun again, all you have to do is look away. So it's totally safe.
Can you wear sunglasses and be looking?
You can. There are special glasses that you can order online. They're called Eclipse glasses. And I recommend that if you want to look directly at the sun, that you only do so with some safety-approved devices like those Eclipse glasses. You can also project the sun's image through what's called like a pinhole camera. You can have like a card and put some aluminum foil on it and punch a little hole in it and then let the sunlight come through and it will form an image of the sun. So you can see the image of the sun partially eclipsed. And then of course that's totally safe.
Well, thank you so much for being here today.
Thank you for having me.
Well, that's on my bucket list. We've come to the end of tonight's show. Until next time, happy trails, and remember, the safest place is on the horse. For everyone here at UWTV, I'm Mary Young saying good night.